Hi, everyone. Thanks so much for joining us today. We're really glad to be here. And for what it's worth, quick plug to the ODSC in-person events. I've been at East, West, and London, and they're all fantastic. So I hope to meet some of you in person. But about today's topic, we have a really cool collaboration here between DataStack Academy and Pandata. And like many in the data science community, even though we've been aware of language models for some time, November 2022 was a momentous day for us as well. And a lot of our clients started asking questions. Well, what are we doing with generative AI? And how do we build applications? And it's a one-part data science problem and a one-part data engineering problem. And so the collaboration between Pandata and DataStack Academy started on that note. And we've been learning through trial and error, like many of our peers. And today we're excited to distill some of the lessons we've learned over the past 6 months. We're going to be talking about tips and tricks and whether this is your first experience thinking about building an enterprise-grade large language model, or you've already gotten your toes wet. We're hoping that you will have something to take away from this discussion. And as always, questions are encouraged. We're all learning together. Really excited to dive in with you all. Before we begin, I figured we'd give a chance for each of us to tell you a little bit more about who we are, and I'll let my colleague Nicholas start us off.
Thank you, Cal. Yeah. Hi, everyone. Great to meet you. I also went to ODSC West, where I met Cal last year. And so that was a fantastic experience. There's a lot of great speakers there and great attendees. But I'm a data science consultant here at Pandata. And prior to this, I was working also as a data scientist. I got my degree from University of San Francisco. And in recent months, I've been working a lot with large language models for a couple of different industries. So I'm really excited to be here.
Awesome. Thank you, Nicholas. Param.
Yeah, thanks again. Thanks everybody for joining. I'm Param. I'm a co-founder of DataStack Academy, where we actually train a lot of data engineers. We're very unique in a data engineering sort of bootcamp or school where we train like state-of-the-art LLM and machine learning and data engineering, sort of ML ops that goes around that. But in my career, I mean, you guys can go on my LinkedIn. I just seem to be lucky and be at the right place at the right time a lot of times, and lucky to be here. Yeah, thanks guys.
Awesome. Thank you, Param. And just a little bit about myself. I'm a data scientist by training. I've been practicing for about 10 years now. And I still remember the vintage days of NLP in the 2012 to 15 area. But I've been fascinated with applying data science and modeling techniques to language for quite some time. So really excited to dive in with you all here. I figured I'd start with a quick rundown of the agenda. We have this broken up into 4 parts roughly, and then time for interactive question and answers. But as questions come up, please pop them into the chat throughout, and we'll try to DJ between the 3 of us as it makes sense. But we're going to start with a quick overview of why now and what are some of the issues with large language models. We'll walk you through some of the tools and techniques that we've learned. And then we'll wrap up with a discussion of risks and how to think about mitigating risks and why you should care about this and advocate for it within your organization. And to start, why are we so excited about language models as of 9 months ago collectively as a society? And I like to put this in context of we're excited about machines performing at human levels. And I want to unpack this quotation just a little bit. There are a lot of benchmark data sets that exist. Some of them did not exist until just a few years ago. But these data sets include a variety of tasks, whether it is optical character recognition in the early days of computer vision, being able to separate out digits, or data sets that have pairings of transcripts and the correct response. And this is a really neat chart that showcases state of the art in each of these functions relative to human performance. Now, what's interesting is it's human performance with no trickery, no real world noise. So these are very idealized data sets. But as of the 2015 and beyond, we started seeing more and more of these applications reach human level performance. And with the advent of the interactive nature of ChatGPT, this really catapulted the technology into the executive sphere of awareness. And so that's the big shift that's happened. And in the time since November 2022, we've had a whole bunch of large language models be released. And Nick, we can go to the next slide, please. And there's an explosion of these, and it's really hard to keep up with. And if you're feeling overwhelmed, that's okay. We are similarly feeling overwhelmed. The thing that matters here is we very quickly learned that the more examples that you provide to these foundation models, the more emergent properties that you start to observe up until a certain point. And so 2023 and beyond, we're seeing now a new wave of more purpose-built, specific models, more optimization on training. And there's two families. There's the open source world, and then there's the proprietary enterprise world. And we're going to dive into some of how you might think about dealing with this. But first, let's not forget, what is AI? And this is a problematic definition. You ask 10 different data scientists, you're going to get 10 different answers, and God forbid you have a data engineering friend, and then you ask them to define it too, and everybody's going to end up with something a little bit different. And a little bit about me, I come from the perspective of having to engage with stakeholders and executives all the time. So I like to start with definitions, and hopefully this is a tool that helps you break it down. But AI is nothing more than software that's recognizing complex patterns. These patterns can be in spreadsheets. They can also be in documents, images, or videos. And the second thing that AI does is it's trying to react to those patterns with some objective. Maybe you're counting the presence of things, maybe you're cataloging or labeling, perhaps you're predicting a future state. And what everyone's excited about, what executives are excited about these days, is this notion of creating new patterns. Now, why does this matter? Traditional software was teaching with instruction. First you do this step, then you do this step. And with artificial intelligence, we're talking about teaching with examples. Here's a pattern that I know how to recognize as an individual, but I don't quite know how to break it down. Like when we look at this, a summary of a newspaper article, for example. We can tell that one summary is probably more faithful than the other, but it's really hard to break that down step by step. And then going to the next slide, the big aha here when it comes to integrating this into the enterprise is now, instead of dealing with procedural-based logic, if this, then this, we're now dealing with confidence-based workflows. There is some percent of the time that you are going to be more confident in the answer, and some percent of the time you cannot trust the answer. And a big part of leveraging these language models correctly in enterprise is knowing when to trust them. And I'll give you an example from one of our first encounters with an enterprise language model application. This was working with a museum of art, and they've got about 60,000 items in their collection online, and they wanted to make it more accessible to individuals with visual challenges or visual perception challenges. And if you use state-of-the-art computer vision models on an art piece like this, it'll say this is a jar. And I don't know how much that helps or hurts the experience of somebody attempting to understand this object. And on the flip side, there is a long section of art history, paragraphs upon paragraphs, that many of us would glaze over if we were reading. So again, that's not quite useful. And we had this idea of what if, back in December, what if we could use language models to combine what we get from computer vision with what we know about the art piece itself, and use a language model to create something with the right prompts that would be more useful for somebody that's trying to understand what this object is about. And we were quite impressed with the results. That being said, they were right around 50 to 60% of the time, and the accuracy wasn't really the big pain point. The pain point was, okay, if we generate this for 60,000 objects and we know 30,000 of them are correct, which 30,000 do humans have to review, right? So we had to come up with another layer of logic. Can we build a model that can then look at this text and based on examples of human experts that said, yes, this was good and appropriate, no, this was not good and appropriate, and we came up with a scoring model that diverges from your typical benchmark data sets that you have available. This one doesn't quite exist. So the punchline of the story here is our encounter with Enterprise LLMs. For the last animation, Nick, is that we had to add some extra layers on it in order to make this useful. And so instead of dealing with this as it's wrong 50% of the time, hey, it's actually safe to apply this at scale in these 20% of the items. Have a human review it in these 30% of the items. Do not touch it in 50% of the items. And I'll turn it over to Parham. This is kind of a little bit of a teaser here, but Parham is going to then talk to you a little bit more about these challenges at scale.
Yeah, thanks a lot, Cal, for setting that up. Exactly, setting the stage here. I want to just set a stage for our presentation here and the challenges that we're going to talk about. Of course, when you're doing an LLM application, you're going to immediately realize that your toughest challenge is the amount of memory or short-term memory or context that these LLMs hold. We all know that that's kind of measured in tokens. ChatGPT 3.5, that was a 4K limit token. In GPT-4, that's 8K to 32K, so it's a little higher and a little easier to work with. We're also going to talk about the decision of the different methods that you're going to use for your LLM project. Like, do we train a model? Do we go with pre-trained model? Do we go with a RAG approach? It's something acronym you're going to hear a lot. Don't worry if you don't know what it is. We're going to talk about it a lot in this presentation, and Nicholas is going to give you a full overview of what it is. But those are some of the methods, for building LLM applications. Do we go with off-the-shelf sort of these proprietary, well-trained models like GPT, or do we invest the time to build and specialize sort of open source models that might have less, intellectual property concerns, but maybe a little bit more development costs? Again, for building an enterprise application, there's a lot of different pieces that you're going to see that comes around the application. The front end, the compute, the storage, the analytical layer, all of those traditional layers that you still have. It's not just the LLM. And again, do we go with cloud or a hosted solution, or are we going to save cost and go with, host it ourselves? And it's, again, and you're going to see the answer is sort of maybe at the end of the line, a hybrid approach, but in beginning to, again, save development time and get to market first, you might choose cloud for that. You might choose the easiest way forward. And like Cal said, at the end of the day, garbage in equals garbage out. So a lot of these LLM applications still have a big data engineering component, a data cleansing component, and the more time you spend to clean up the data, that means that your model is going to perform more accurately, and you're actually going to use less tokens because you don't feed as much junk into the model. So your results is going to be better. I think by far where you see the biggest difference is the amount of time that you spend in prompt engineering, and that's going to really make the most effect on your fine-tuning the model. And then you have things consider like caching your prompts and caching your responses. Again, that saves cost because you don't have to make so many API calls to the GPT or to the model, and it also going to increase speed. So let's dive into these one by one. To build, again, the context for this, you're going to hear us talk about this project that we did together. We're very honored to work with Pandata on this project. And this is a project that had a lot of data engineering pieces, a lot of ML ops pieces, a lot of actually building front-end application for this, and again, a lot of data science, LLM, and fine-tuning the model and putting a lot of guardrails to validate the model output and so forth. For this one, our client was called Action Responder. They're a legal startup that help trademark attorneys file a trademark application. So what usually happens when you try to go file a trademark application, you send your application to US Patent Office, and then the examining officer of US Patent Office will give you a bunch of rejection reasons. You know, they almost never accept your application on the first run, of course. And then the rejection reasons are things like, okay, this trademark is too similar with another trademark, maybe creating confusion for the users, not descriptive enough. And then the filing attorney or your attorney gets to refute that, right? Gets to provide a lot of reasons and actually provide a lot of other cases where the trademark was accepted and was kind of similar to yours. And that whole process takes a lot of time, right? Like takes a lot of time for the attorneys. Time means more money for you. So what we did, we want to automate that, and not fully automate it. So still, you know, maybe 80–90% there, but to create a template of responses that the filing attorney can use and go from there. What I want to emphasize here that we started with a very simple MVP, and our architecture was very simple again here. And do that, right? So when you're building your MVP, make sure you start very simple, and then it gets much more complex, which we're going to see here. So in our case, patents information are all public. So we scraped the USPTO office for a lot of relevant information. We built actually a repository of case law. So a repository of similar trademark cases that we could cite, and that's very important for citing those cases for your application to be approved. And we decided to break down our approach into multiple steps. So usually your trademark application, again, gets rejected for a lot of different reasons. Instead of tackling all the reasons at once, we tackled it one by one, which allows us to be more accurate in our responses, and we don't hit those token limits, right? And then we carefully crafted a response, and this is where prompt engineering comes into effect. So we carefully crafted a prompt that had the right kind of mix of context from the original application, the rejection reasons, other cases that should help you respond that are similar. And then we went back at the end and put together a cohesive response. So another layer that put all of these responses together and made a final kind of argument. Simple, right? MVP, but we're gonna dive into this. Before I dive into our enterprise architecture, I want to really say the importance of defining metrics for the success, or defining metrics that you can measure the performance of the model, and do that early on. You want to make sure you have a right mix of qualitative and quantitative metrics, and keep those simple. Keep a handful of metrics that you can keep measuring and see the performance improvements of your model. For us, it was, again, very simple. It was like, is the model making persuasive arguments? Do they have depth to it? Do we actually respond to all the reasons, all the rejections? And do we cite accurate case laws? Or we hallucinated, which we actually did quite a bit in the beginning. So it was very important actually you cite accurate case laws, because if you don't cite accurate case laws, right, you made a very bad argument. And from there, again, our MVP really grew. So once we built this MVP, once we knew that, okay, we can make very persuasive arguments in this case, then you start seeing that you're going to build a lot of these enterprise components around your MVP. And if you're going to go with the RAG-based approach, which again, we're going to talk about in a second what RAG-based is, you're most likely going to need an embeddings database. What are embeddings? Embeddings are a vector format of your data, your specific data that GPT or the LLM has not seen. Just like computers understand numbers in zeros and ones, Language models understand language in embeddings, a vector format of numbers. And you're going to use something like Pinecone and Lambda Index for that. You have your core layer, but you also going to, again, think about caching, perhaps implementing caching layer, which really would help you actually in development phase where you're trying a lot of different prompts, response, and maybe you're trying the same prompt. So instead of asking GPT again, you just go with your cache layer. So it has a lot of cost benefits and actually speed and performance benefits. Develop that early on. You're going to think about how to observe and log and monitor the performance of your model. This is where tools like weights and biases really come in handy. And you have to think about validating the model's response, like Cal mentioned. Is this response actually accurate? Does it comply to all the rules that we have? Did it hallucinate? So this is where things like guardrails really come in handy. And aside from these, right, you have a lot of your traditional pieces. You still have to build an application. So you need a front layer, you need APIs. You still need an analytical layer to see what the users are doing, what prompts you send back, and that has an AI and ML on its own, right? So there's a lot of pieces that come into effect, and Nicholas is going to go in depth and talk in depth about those in a second. But before that, let me jump into one of the big questions that comes up. And Nicholas, if you go next, please. Thank you. Perfect. I mean, as again, Cal mentioned, there's so many LLMs out there. There are a lot of proprietary LLMs. There are a lot of open source, and we all a little at the first stage confused which one we're going to go with, right? And while there's no right answers, I want to say that yes, a lot of proprietary LLMs have probably intellectual property concerns, cost concerns at the end of the day. But when you initially start, time to market is very important from a business perspective. And I know we have executives here. So this industry is moving quick. If you're building an application, being first to market is very important. So in my opinion, you start really building on proprietary, maybe off-the-shelf, highly trained models that reduces your development time, that gets you to the market first. But keep in mind that at some point, you're going to go back and replace people or pieces with open source pieces, and that's going to take you some development time. But at the end of the day, it's going to get you, much better performance, less costs, better intellectual property. You own those pieces. That's the same with going with cloud versus hosting, in my opinion, as well. To really reduce your development time in beginning, you just go with cloud, use the services as you have, use PaaS, use SaaS. But again, at some point, you're going to reduce your costs because you're going to see these models take a lot of time to compute. And you might go with a hybrid approach where you take some of those compute or storage and you build it, locally. That's our advice. And to tee this off, again, we talked a lot about different methods of LLM. So I'm going to talk about training versus RAG. So training a model, again, very highly generalizing LLM applications. These are some of the methods that you have. You either spend the time to train a model, and that's like taking an exam, like taking a class, taking a semester class, really learning the material, and then going to take an exam. Now, this process, of course, is a lot more resource intensive. You have to actually go learn, but it's more prone to hallucination because what you trained a model, it kind of all that stuff gets meshed in with its long-term memory, with the memory that it's had. So your data kind of gets meshed in there. So it might be more likely that the model would just go to its other memory because your data and your memory is kind of meshed in there and will give you something that's not relevant. Versus RAG stands for Retrieval Augmented Generation. It's like take an exam where you have not taken the class at all, and you just have open book exam and you have really good study cards. So you get a question, somebody hands you just the perfect study cards for that question. You take a look at them and you come up with the answer. So in this case, this is much more accurate sometimes and precise. It takes less resources because you didn't take the class for a whole semester, right? And but again, it has those token limits issues and so forth. And with this, I'm going to hand it off to Nicholas, which will really talk details of this, this method. And just to set the stage here again, in this particular webinar, we're only going to talk about RAP, again, because it has the best, like I think, in our opinion, we've had very good success with it, and it's less resource intensive. Again, gets you time to market faster. Nicholas, all yours.
Yeah, thank you, Par. I really like that visual of the study cards, because I've definitely done the process of I write too many study cards and then it's test day and I'm like scrambling to figure out which study card is relevant. Yeah, I was just thinking it would have been nice to have a nice retrieval system for that process. But jumping in here, before we talk about RAG, I kind of want to just show what traditional question answering looks like with LLMs. And here we have a user who asks a question. This is something that we perceive as kind of our input prompt. The large language model, like Par mentioned, learned all its information during training. So it does have that out-of-the-box functionality, which is great. But it's going to generate the answer based on what it thinks the response should look like. What's the most likely response to the question you answered or the question you asked? So depending on the training data, which is very vast in how it stores all that information, it could be more prone to hallucinations. And that's going to be a common theme, this concept of how do we reduce our risk of hallucinations and get better responses. And the second or third biggest con here for this traditional approach is when you want a product that's relevant, that uses new information, it becomes very difficult to do that in this simplistic pipeline. Because the large language model learns all its information during training, you'd either have to retrain the model with new information, you'd have to maybe fine tune the model, or you have to put the burden on the user to essentially ask a question and give information that includes the answer to the model, which isn't maybe a realistic assumption here. So this ties in really well with retrieval augmented generation, which is definitely a mouthful. So I'll try to refer it to just RAG, where we have our user who asks a question, our initial prompt. And prior to the large language model answering, we go through a process of smart search. Where we have our private knowledge base, which could include different types of documents. It can include a lot of information that we have hand selected. And we use our initial prompt to find which chunks of information are the most relevant. So with Par's analogy on the study cards, you could imagine our specific knowledge base is the stack of 1,000 study cards I made for my test. And our smart search selects, the 2 or 3 or however many we decide, most relevant cards for the question I'm looking at. This information then goes to our large language model, and we are able to get a response that can reference directly the documents from our knowledge base. So this reduces our chances of hallucinations. And just to go over this maybe one more time with a precise example from Action Responder, let's say a user wanted to summarize a very specific trademark. So trademark 7231843. I don't think this is an actual trademark, but it's a serial number that refers to it. And this goes through our smart search process, where here you can imagine our knowledge base includes trademark applications, maybe office action responses. And there's also this concept of metadata, which in this case is the trademark serial number and the type of document. And so you can think of metadata as a way to tag your documents so that it's easier to find it. You can imagine having a file system on your computer where you put everything in your documents folder, or you can start creating folders and starting to organize everything so it's easier to find the precise documents you're looking for. So with this ask from the user to summarize the office action rejections, we then take the most relevant chunks of information from using smart search. We append that to our initial prompt, So here in bold, you can see that we take those relevant chunks and we put it in the precise prompt we're feeding into the LLM, which then gives us a response that's able to answer our question with relevant documents and able to cite the sources that it used. Now, as we've heard mentioned a couple times now, there's this concept of garbage in and garbage out, which means that no matter how great of a model you may have, if you have bad data going into that model, you can't expect great results to come out of it. So this is especially true with the RAG approach, because at the end of the day, you're enhancing your prompt with your knowledge base. And so you want to make sure that that enhancement is always going to be helpful to answering the question. So data curation is super critical here. You don't want to throw all of the information you can find in your knowledge base. You want to be cognizant of what's the goal with that specific application and what knowledge does it need to answer that goal. There's also the concept of data cleansing, where there's a lot of traditional ETL techniques, such as removing duplicate documents, cleaning the text up a little bit, maybe removing special characters, and something that's really relevant to certain industries, like you can imagine trademark applications or other legal documents like patent information. There's a lot of boilerplate text that's not necessarily needed for the model to answer the question, but is included in all of these applications. So it's really useful to take your time when it comes to cleaning your data and pre-processing it, so that you only include the relevant information in your knowledge base. And finally, there's a lot of decisions that need to be made in the process of deciding how you split your text, how big of a chunk size you want to create, what embeddings you use, as well as how you want to incorporate metadata into your documents. And this is actually, the metadata bit can be augmented a lot with new LLM approaches, where they have methods of looking at a document and generating smart tags that you can then use in your metadata. So that's a really cool use case right there. But just to take a step back from retrieval augmented generation, RAG is just a single technique. There are a lot of different techniques out there. This is not a complete list by any means. And I feel like every week or every 2 weeks, I hear about a new technique that's out that's having success in a certain task. And something that I would mention is that, one technique or one best combination of techniques isn't going to solve every problem. This is part of the art of prompt engineering, is you need to have a modular enough system in your application to be able to test these different combinations of techniques. And one combination that we saw have a lot of success in our action responder was combining few shot prompting with instruction prompting with our RAG approach. Now, few shot prompting is the idea of, let's ask the LLM to do something, but let's give it examples of what we'd expect. So this tends to help a lot with GPT-4 models, with other GPT-3 or Llama 2 models that might not perform as well, that need those referenced examples. And instruction prompting here is pretty intuitive. It's essentially breaking down a more complex task into different specific tasks. So it's more simple tasks. So here we have a simplified version of what that might look like, where we want to analyze the context from a TSDR application. We use our RAG approach to retrieve the most relevant information in our knowledge base, and we put it within the prompt context. We then use instruction prompting to break apart the steps we want the LLM to go through. And in this case, we wanted a very specific output. We wanted it to look like this applicant mark and then list all the applicant marks and then list all the cited marks. And so for this case, we included few shot examples. And I cut it off here, but there were a few other examples below that really helped make sure that we had reliable results, so that we can then take that result and put it into a different part of the pipeline. And just to take a step into what Par was mentioning previously, this idea of caching versus recalculating, regardless of the decision you make with prompt engineering techniques, we highly recommend that you think about caching early because it can help both in production, but also in your development. And in this way, using the similar visual that we saw before, right before we prompt the large language model, we can look to see if that question has been answered already. If it has, we can just use that answer that we've saved, that we've cached. If it hasn't, we'll go through the normal pipeline and we'll ask the large language model to generate a response. And then we can cache that new response so that next time we're prepared. So we highly recommend this approach just because it's going to, like Par mentioned, save some money on the API calls and allow for a bit more flexibility when it comes to doing a lot of experiments during development. And finally here, I wanted to take a second to briefly talk about guardrails. This visual itself is a visual from Nemo Guardrails, which is an NVIDIA product, which does a lot of great things for the security of your application. And it's a fairly, with any machine learning model, there's this idea of controlled expectations. And so guardrails here allow us to have some controlled expectations of our large language model in production, whether it's going to a user or if it's just part of that pipeline. There's also, specifically with chatbots, the ability to do dialogue flow, which essentially means, can we help control the dialogue a little bit so that it's not an open-ended free dialogue with a chatbot. And finally, to refer back to the prompt I showed before, we wanted a very specific output that looked like a JSON object with the applicant mark and the cited mark. Guardrails here allow us to enforce that type. And if it doesn't reach that result that we expect, it can go through what we call corrective action. So it can try different prompts to get that result so that if the pipeline breaks, we have already a plan B in place. And with that, I'd love to hand it off to Cal to talk about the other risks out there and how we can mitigate it.
Awesome. Unfortunately, I think we've all been in the room at some point where you bring up the fact that, all right, these things are kind of flimsy, and then someone says, well, we don't need to worry about that right now. We just need to get this ready for production. And so my goal in bringing us home here is giving you the tools, but also showing you some evidence that these are in fact challenges that need to be addressed. This is from the Stanford Center for Human-Centered AI. They do an annual state of the industry report out, and this was looking at 2022. There is a growing number of publicly visible controversies related to the use of AI. Some of them we've experienced. The launch of Apple's credit card, for example, that uses machine learning to determine credit limits. Would give a lower limit to women in the same household where a man would get a higher credit limit. And so as modeling has become more accessible, as getting access to data has become more accessible, it's also become easier to break these models as they make their way into production. And I wanted to walk through a couple of examples of how we think about measuring these potential risks and what you can do about them. I really enjoy the demos that are assembled by the Allen Institute for AI. They do a lot of this risk-based research, and one of the methods that they use that you can also think about in your stress testing is underspecified questions. So they provide context to a language model. For example, in this first question, the person over the swing is Angela, sitting by the side is Patrick. And then they ask a question that isn't related to the context. And the goal here is attempting to uncover what the model infers, or if the model is biased in one way or another related to protected attributes like gender, religion, ethnicity, etc. And they automate the generation of these tests at scale. They take templated sentences, they swap out the names from a list of references, and they then start to measure the apparent biases in these models. And if you go to their website, This is based off of BERT, but they've also done it with Distilbert, Roberta, and other embedding representations. The same techniques also apply to the embeddings that are used in language models like GPT-4, for example. So if we can animate this, what you end up seeing with this type of stress test is that in each of these questions, the model responds with a very problematic answer. And they start to benchmark this across thousands of benchmarks to understand which models are most prone to bias. An interesting finding that they had, and if we can go to the next slide, is that the larger the models, the more prone they are to biases, unless the reference data set has gone through additional curation intentionally to minimize the presence of those biases. And just looking at BERT alone over here, you can see that there is a preference to have lower sentiment for ethnicities, for example, that are Arab or African in heritage versus those that are European or Jewish in heritage. And that's just one example of the type of stress testing that you can do with language models. But moving on, it's not just whether or not the model is inherently biased. Models are also easily fooled. And so this was another great paper that was put out by OpenAI with computer vision, a pretty solved for problem. And early on in this talk, we showed the human level benchmarks. So when you show this computer vision solution an apple, it says, yes, this is an apple. There's a very low probability it's anything else. And the chainsaw is in fact a chainsaw. And then you can use simple manipulation with a low piece of tech, a sticky note, and you can convince the computer vision model that it's looking at an iPod and that it's looking at a piggy bank with the introduction of dollar signs. The same is true with language models. And I'll show an example of what that looks like. But just to start to address this challenge of risk with generative AI, we have very poor baselines for what is considered correct behavior. And the harder it is to define ground truth, the more you expose yourself to risk. Recently, an MIT student used an app that uses image enhancement that is based on generative models. And when asking for a more professional version of her selfie, it turned her from an Asian woman into a Caucasian woman with blue eyes. And so what is the baseline for correct? And how do we scan for these? Next slide, please. Prompt injection is something that I alluded to earlier. And it's this notion that a language model by design is meant to handle a lot of language prompts that it hasn't already been exposed to. But what that also means is that you can expose it to malicious intent. And there's a lot of examples of jailbreaking ChatGPT out there. I do not recommend it. However, there are little things like adding a series of asterisks and explanation points that allow you to get these models to behave in very weird ways. If you're curious, there's also a fun set of these jailbreaks that happen with generative art like Midjourney that result in weird characters coming up over and over again if you use the right sequence. And what this does is it opens up also security vulnerabilities. You can have malicious actors, for example, if you're building a chat experience, introduce message headers or automatically bombard a chatbot with these types of hacked prompts that get the model to behave in a weird way. Check this demo out by Lakera. It's really great. It's got 7 different levels, and you try to get it to reveal the password with a bunch of different manipulations. But it gives you a chance hands-on to see how these language models can be broken. And then I'll end with discussing a little bit more about the risks, right? Machine learning has always been prone to challenges with bias and challenges with unintended consequences. But with the advent of generative AI, we've all been exposed to hallucination by this point, and we've seen the wonderful, fun images that can be created that look very authentic, or news stories that look authentic. In fact, there's an article that just came out last week that highlighted a whole bunch of books that are being generated and published under the names of authors that didn't actually write them. And this is a whole new farm of content creation. But let's assume for a moment that everyone here in this audience has good intent. So some of the challenges that you'll want to consider is, to what extent are the results being generated by your language model similar enough to something else where it could be subject to copyright laws? To what extent might your model be put in a situation where it gives a biased answer or a harmfully biased answer or responds in an inappropriate way? And a great way to think about the level of risk you're being exposed to is on this next slide. I like to lay out this visual. The more complex your data, the harder it is to query. The least complex data is spreadsheets. You get a little bit more complicated with documents. You can still write examples that are queryable, but as your data gets more complex, it's harder to define those edge cases that you want to test for. And similarly, the more complex your goal is, the harder it is to define ground truth. When we're counting things, we can always reference our baseline, how many of them were there. When we're predicting a future state or labeling items, we have a reference set. But as soon as we start getting into this world of generative, where if I had asked everybody in this webinar to summarize this talk in 2 or 3 sentences, I guarantee you we wouldn't get the same answer, even though you've all seen the same content. When multiple equally correct answers are possible, it becomes much more difficult to define correct. And so you have this intersection of 2 things. You have difficulty to query, difficulty in defining ground truth, and this needs us to start to verify and validate and manage the risk of these models in a slightly different way. And we've been doing this for a very long time in other industries like manufacturing. An airplane wing, for example, as it's being designed and before it's ever deployed on an actual aircraft, is stress tested tens of thousands of times and exposed to multiple orders of magnitude of stress relative to what it would be exposed to in practice. And so I end with this call to action of, if you think that guardrails aren't important, if you think risk management is something that you can add as an afterthought, it's important to start managing this in your design and development process and to advocate for it. And for what it's worth, stress testing language models can be quite fun. You get to be the most obnoxious version of yourself, and you get to see how far you can push these language models. And so it can be really fun to develop those test cases, automate them, generate them at scale, and try to understand where they might be exposed to failure. That being said, I want to invite you all to ask us some questions. We can make this a little bit more interactive. We've got a couple of follow-ups here. We have a fireside chat coming up on September 26th that, should you want to attend and have it be more conversational, show up with your use cases and examples, will be available to answer and work through and workshop some of those. And if you want to reach out to us on LinkedIn, feel free to give us drop us a message and say hello. We'd love to hear from you and hear what you're up to. So that being said, I'll see if we have any questions.